as you can see by the title of this smartboard, which, by the way, I don't know if you know, the title is up here. The title of this smartboard is Tap the Brakes. Okay? All right? So we are going to tap the brakes. Okay? Okay? But with tapping the brakes today comes flipped video for tomorrow. Okay? So there will be a flipped video tomorrow. Now Q8 is all about... So Q8 is all about working on the Inspire. Okay? And so what we're going to do then is I'm going to make a video sometime this afternoon about how to do it on the Inspire. If you have an Inspire with you while you're watching the video, you can play along. If not, we're going to work tomorrow in class solely on the calculators and how to do all this stuff on the calculators. Now, the downfall is that tomorrow is extended homeroom. Okay? And I don't know what they're doing with the extended homeroom. If they're just going to chop off those mods because the afternoon mods are already chopped off, or if they're going to shorten mods, and they haven't told us yet. I don't know. So I don't know if I have class tomorrow yet in order to do that. If we do have class, I know it will be short. If we don't have class, the video is still there for you to do, and then we can just pick up on it on Monday. Because Monday is also a calculator. Okay? So we've got that going on. Okay? So that's why we're going to tap the brakes today, and we're going to go back. We're going to do some matrix multiplication type stuff, and then we're going to do some Cramer's rule type stuff, and we're going to solve some by matrix, solve some systems by matrices. Okay? So my question to you is, can I multiply those two matrices together? Can I do it first and foremost? Why? So the middles are the same. Okay? So this matrix over here is a 2-row by 3-column matrix. This right matrix here is a 3-row by 2-column matrix. And Tasha said that these two numbers have to be the same. In order to multiply, those two middle numbers have to be the same. Now, what else do we get out of writing down the dimensions? The dimensions of my answer is going to be it's going to be a 2 by 2 matrix. So this over here, and me, I like to draw a nice sized 2 by 2 matrix. Okay? Now, we just have to fill in that 2 by 2 matrix. Okay? So, I am going to look here, and this is row number 1, column number 1. So that means I'm going to take row number 1, and I'm going to multiply it by column number 1. So that's going to be 1 times 0 plus negative 3 times 4 plus 10 times 8. 1 times 0 is 0. Negative 3 times 4 is negative 12. 10 times 8 is 80. 0 plus negative 12 plus 80 is 68. Then I can go on to row 1, column 2. So I'm going to take row number 1 and multiply it by column number 2. So that is 1 times 1 plus negative 3 times negative 2 plus 10 times negative 3. 1 plus 6 plus negative 30. Negative 23. Row 2, column 1. So now I'm down here and there. So that's going to be negative 2 times 0 plus 7 times 4 plus 8 times 8. So that's 0 plus 28 plus 64, 92. And lastly, row 2, column 2 is going to be row 2, column 2, negative 2 times 1 plus 7 times negative 2 plus 8 times negative 3. Negative 2 minus 14 is negative 16, minus 24 is negative 40. So my resulting matrix is 68, negative 23, 92, negative 40. Okay? Now, my question to you would be, if I did that in the opposite order, like how 2 times 3 is 6 and 3 times 2 is 6, would I get the exact same answer? That's my question to you. If I flip the order of those two matrices, do I get the exact same answer? Yes or no? Do it and find out. All right, so dimensions wise, can we do this one? Yeah, what do we get though? We get a 3 by 3. So right away, they're not the same. Okay? So it's going to be a whole different thing. And we could have known that because matrix multiplication order matters. Okay? When you're multiplying matrices, the order in which you multiply them matters. Okay? So this is going to be row 1 times column 1. So that's 0 times 1 plus 1 times negative 2. That's going to be negative 2. Row 1 times column 2 is going to be 0 times negative 3 plus 1 times 7. That's going to be 7. Row 1 times column 3 is going to be 0 times 10 plus 1 times 8, which is 8. Row 2 times column 1 is going to be 4 times 1 plus negative 2 times negative 2. That's going to be 8. Row 2 times column 2 is going to be 4 times negative 3 plus negative 2 times 7, negative 12, negative 14, negative 26. Row 2 times column 3 is going to be 4 times 10 plus negative 2 times 8, that's going to be 24. Row 3 times column number 1 is going to be 8 times 1 plus negative 3 times negative 2, that's going to be 14. Row 3 times column 2, 8 times negative 3 plus negative 3 times 7 is going to be negative 45. Row 3 times column 3 is going to be 8 times 10 plus negative 3 times 8 is 56. So the 3 by 3 matrix then is negative 2, 7, 8, 8, negative 26, 24, 14, negative 45, and 56. Yes'm. Okay. So we got that going for us. So order definitely matters in terms of matrix multiplication. Same two matrices multiplied in a different order got us two different sized matrices. Okay? What I would like you to do now is I would like you to solve this system of equation using Kramer's rule. So, Kramer's rule, remember, uses determinants to solve for us. Okay? So if I want to solve for x, I'm going to set up a fraction. The denominator of my fraction is going to be my 4 coefficients. 2, 3, 5, and 2. Yes? Okay, my 4 coefficients. The numerator is going to take the 2x coefficients and replace those with my constants. And now I can find the value of the determinants. Remember, it's Chris minus cross. So that's going to be negative 7 times 2 minus 10 times 3 on the top. On the bottom, it's going to be 2 times 2 minus 5 times 3. So that's going to be negative 14 minus 30 all over 4 minus 15, which is negative 44 over negative 11. So x here is equal to 4. Okay. Now, I could take 4 and I could plug it back into one of my equations. Because it's 4 minus 15. Okay? All right? Or I could set up the other Kramer's rule for y, where now I replace the y coefficients with negative 7 and 10. And I already know that the denominator is equal to negative 11, because the denominator is going to be the same. Okay? So this would be 2 times 10 minus 5 times negative 7 breaks. Why is it acting all goofy on this slide? Oh well, too bad. Gonna have to deal with it. All over negative 11. So that is 20 minus negative 35 all over negative 11, which is positive 55 all over negative 11. So y is equal to negative 5. So my answer in point form would be 4 comma negative 5, or I could write it out as x equals 4 and y equals negative 5. Yes? Okay. Good? Everybody good with Cramer's rule? All right. Now, we're going to solve the exact same problem. Sure. Sure we are. Yeah. We're going to do it. Come on. I know you want to. There it goes. All right. So we're going to solve the exact same problem, but now we're going to solve it using matrices, which is what we started yesterday. And we whipped through it because we were short on time. So the first thing that we need to do is we need to make our matrix equation. What's the first matrix that we write down? It's the coefficient matrix. So what is it, Eddie? 2, 3, 5, and 2 is our first coefficients of the variables matrix. Okay? What's our second one? The variables. So that's x and y. What's our third one? The constants. So that's going to be negative 7 and 10. Now I know, because we're doing the exact same problem, I know the answer already. X is going to be 4, y is going to be negative 5. If we get something different, something like cray-cray, when that slide wouldn't change. Okay? So we know that answer already. Now, let's take a step back and let's talk a little bit about matrix multiplication here. So I've got matrix A times matrix X, and that's going to equal matrix B. So I've got my blue matrix times my black matrix equals my red matrix. Okay? Now, I want to get rid of this one because I want to solve for matrix X. So in order to do that, I have to multiply, because I can't divide matrices, so I got to multiply by the inverse. And the cool thing about multiplying by an inverse is it goes away. But because I multiplied by the inverse on the left side, I've got to multiply by the inverse over here on the left side. Because those first two slides we did today taught us order matters. Okay? So what we first need to do is we first need to find that inverse of the blue matrix. So if I'm going to find the inverse of the blue, what's the first thing that I have to do? Find the determinant. What's the value of the determinant of the blue matrix? Negative 11. We actually found it when we did Cramer's rule. Okay, it was our denominator in Cramer's rule. So the inverse is going to be 1 over negative 11. Then my matrix is going to be, I do what? So I switch the 2's. So I switch the main diagonal, right? In this case, they both happen to be 2's, so they're going to stay 2's. And then I put negatives on the 5 and on the 3. With me on that so far? Okay. So if I follow my abstractedness over here, that's going to tell me then that, oops, let me go down here a little bit farther. That's going to tell me then that matrix XY, my black matrix, which I'm trying to solve for, is going to equal my inverse matrix, which I just found, times my constant matrix. Right? Do that quickly for me. Should have gotten x equals 4 and y equals negative 5. Now, if you wanted to leave it like that, because it's a matrix equation, we're fine with that. If you wanted to write it as a point, we're fine with that. If you wanted to write it out, I'm fine with that too. Okay? But we get the same.
How did you know from the 1 over negative 11 with the negative 44 over 55 to 4 negative 5?
Because it distributes in. It's scalar multiplication. So this gets multiplied to that one, and then it gets multiplied to that one. So negative 44 divided by negative 11 gets me the positive 4, and positive 55 divided by the negative 11 gets me the negative 5. Okay? Hopefully that has cleared some things up. Okay? So that you can get yourselves through Q7 and watch the flipped video for tomorrow. Okay? Have a great day.